In this question, it is given that a metallic block A of square cross-section area A, length D and thermal conductivity K1 is in contact with two blocks B and C, each of area of cross-section A by 2, length D by 2 and thermal conductivity K2 and K3 respectively, and placed on top of the other as shown in figure. If the left side of A is at a temperature of T2 and right side of B is at B and C are at a temperature of T1, where T2 is greater than T1, so this T2 is greater than that of T1, the effective thermal conductivity of combination is. So here you can say that there will be a flow of heat energy from a high temperature region to a low temperature region. So we can just for calculation purpose, we can just consider that the series as well as parallel combination of resistors. So we'll just consider it as like resistors, and if we are considering it as resistors, so we can imagine it like this. There is a resistor of resistance, let's say R1, and there is another resistor over here of resistance R2, and there is a resistor of resistance, let's say that is equal to R3. So we can say that these resistors are arranged something like this. That means this R2 and R3 are connected in parallel, and that combination is connected in series with the resistor of resistance R1. Now we can write the equation for their resistance. Resistance of first resistor R1 is equal to, we can write this L. L is nothing but K. So we know the equation for resistance is equal to L by Ka. Over here length of the first resistor is D and its conductivity is K1, and area of cross section we can take it as nothing but A. Like that we can write the value of R2. R2 we can take it as nothing but its length we can take it as D divided by 2, and its conductivity is K2, and area of cross section is nothing but A divided by 2, because area of this portion is half of the area of the entire conductor. So we can cancel this 2 and this 2. So this we can write this is equal to nothing but D divided by K2A. Like that we can write the equation for R3. The length of that is nothing but D divided by 2, and its conductivity is nothing but K3, and area we can take it as A divided by 2. So we can again cancel this 2 and this 2. So this is going to be D divided by K3 into A. Now we can put these values to find out the equivalent resistance, because these two resistors are connected in parallel. So first we can find out the equivalent resistance of R2 and R3. This R2 and R3. So we can write this as 1 divided by R2 plus 1 divided by R3 is equal to 1 divided by the equivalent resistance of this combination. So we can write it as 1 divided by R2 is nothing but D divided by K2A plus R3 can be written as nothing but D divided by K3A is equal to, we can take it as 1 divided by R. So we can write this as equal to basically K2 plus K3 into A divided by D is the value of 1 by R. So the value of R can be written as D divided by K2 plus K3 into A. Now we can add the value of R1 with it, because R1 and this combination are in series. So we can write R1 plus the combination of R2 plus R, which is equal to the value of equivalent resistance. So the value of R1 we can take it as the value of R1 is D divided by K1A. So we can write D divided by K1A plus the value of R is D divided by K2 plus K3 into A is equal to the equivalent resistance of combination. The total length of that combination is D plus D by 2, which we can take it as something but 3D by 2 divided by the value of conductivity, which we can take it as K, and area of cross section we can take it as something but A. So we can observe that this D over here get cancelled and this A over here get cancelled. So we can write the value of this something like this, that is 1 divided by K1 plus 1 divided by K2 plus K3 is equal to nothing but 3 divided by 2K. Or our aim is to find out the value of K, so we can write K is equal to nothing but 3 divided by 2 into this term we can take it as 1 divided by 1 by K1 plus 1 divided by K2 plus K3. Or if you want, you can write it on the numerator, so we can write it in this form. This is 3 by 2 into K1 plus 1 divided by K2 plus K3 raised to minus 1.